With the fridge, technology and headaches, I will show you how to make this handy device that's really handful. Hey, I have a problem. Let me show you. This is my 200-gallon reef tank. It hosts a variety of fish and corals. But since I'm traveling a lot for work, I can't feed them as much as I'd like to with its mix of shrimp, squid and salmon that I chop by hand. The issue is that sometimes they take it out of my hand. It would then end up somewhere back there. But I finally found a solution to all my problems. A frozen food dispenser that will provide automatically thawed food for the fish and other animals will benefit from it. I bought this cheap fridge for under 50 euros. I will put a link in the description for all the parts necessary for the build. Keep in mind that I've selected the easiest part to build rather than the best performing one. The way it works is simple. A pump takes a solution containing water and food and push it all in a tube to the tank. I'm going to use more precise peristaltic pump for the build. Next, I test the setup by adding food coloring to define the proper cycle to ensure that no food remains in the tube and preventing spoilage. The cycle is quite complex, but I have multiple flush to make sure that there is no food in the tube. During my test, I had one issue with those pumps. It wasn't pumping any liquid because of this pinhole, but it was an easy fix. Just cut it shorter and reinsert that tube in. These tests were made using simple buttons. Now that everything is working fine and the cycle defined, I can work on the definitive solution. The 3D printed brackets is really handy because it allows some movement from the pump to reduce any vibration, but also fits perfectly fine in the fridge. To me, that looks sturdy enough. Next, I'm adding some bulkhead to keep it airtight, but also allowing me to connect and disconnect the tube easily. They will be placed at the bottom of the fridge. Even though I would prefer on the top, it would avoid obstructing the container. Make sure that when you drill the hole, to make them high enough so it's not inside of the insulation. Ask me how I know it. They are normally held by nuts, but since it is too thick, I won't use them, and we are going to use some elbow to hold them. The last hole that we have to make is to pass the cable. Also make sure they are long enough in case you need to do some maintenance. This is the bracket that will hold all the electronic components. My initial plan was to mount everything inside, but I was afraid that humidity will make everything rust with time. So it's a safer bet to install them outside. Airflow around the components are critical to prevent any overheating since we use some older material. Those motor drivers that I choose are not the best nor the most efficient. On the positive side, they can manage 2 motors per driver. They have a regulator to reduce the voltage from 12 volts to 5 volts. This will supply our ESP32. They have screw-on terminal, so you don't even have to make a custom PCB for it. And the last one, they are cheap. I think this is enough, since we will only use the motor a few times a day. One step closer to the target. The plumbing is the part that I hated the most during the process. Now that I think about it, I'm not sure. Those connectors are not working with silicone tube, so I'm using some 1/4 inch just for the connection. In the end, the silicone tubing was a bad idea. They won't even fit on the connection of the pump, so I ended up replacing them. I bought these for 4mm internal diameters, but it seems that my air tube that is the same dimension are working fine. Finding the right container was a hard task, since I had to fit a second one for the dilution. And then I finally found one! From IKEA. It was the perfect fit, but I wanted more room, so it's more practical to use. And it didn't end well. I'll get back to my first idea and use this picture, but there was an issue with the size. And I cannot tolerate being lied to. Not so hard to find a container, right? It seems that everything is hard, even the code. But you won't have to struggle since I will provide it.
Something came in my mind. How did the water get into the coconut?
Time to get back to work.
A 100 days ago, it all started like this. With the help of technology and science. Welcome to the Oasis.
And since it didn't want to work, I had another great idea. It is working. I've made it so it's simple and self-hosted. It doesn't need any app or cloud. For the middle containers, I used one that is 200 milliliters, plenty enough to contain the food. It is made by Philips and is normally used to contain milk. I couldn't find anything that would fit beside the pitcher, so that was the only solution, and it ended up working well. It is all done. Time for the final cleanup, so we can test in real condition with one of the most difficult guests. I will try first with some frozen brine shrimps. They are much smaller than the food I make. There is one tube that goes into the food and 3 to the middle container. I'm happy with the small pitcher. As you can see, it's quite easy to load it. I added one cycle in the program where the pump will run reverse to stir it. At first, the fish were quite afraid of the tube hanging on top of the tank. They hide and refuse to eat for the whole day. During that time, I worked on the quantity of food to deliver, and it worked quite well. The water was nutrient rich from the food, and the other animals benefits from it. And the next day, they all came to eat. The feeder is really helpful since it can provide a regular and frequent quantity of food that I can define on my phone or my computer. Even better, since I built it from scratch, I can modify it to feed different type of food at the same time. It could be a variety of cyclops, brine shrimps, squid, and shrimp. But it must fit in the tube of the pump.